Kalau tinggal.
Assalamualaikum.
Waalaikumsalam. How are you, doctor?
Okay, I am okay. Lukman can hear me properly, right? And it is visible, right? Audible and
Yes.
visible.
Everything clear.
Okay. Alhamdulillah. So actually our participant and honorable guest all are arrived. Our invited speaker.
Yes, they are here, but I think they're still at the stage. They're still listening to the talk.
Okay. I think we have to begin after 10 minutes. But before starting, we have to check something. I mean, just 3-4 lines we have to tell. So no problem. Inshallah, we
Okay,
can.
no problem. Even
We wait
me,
for them.
yeah, we are waiting for Afrin. We can test a few things with Afrin. Because
Okay. So
because even I have to check a few things with Afrin about the sound and everything. So yeah.
Okay. I'm just giving her missed call. Then actually she is in the stage. I think she's at the stage.
Yeah, probably.
So I call her to join.
Okay, that will be good, doctor. Thank you.
Walaikum salam. Kindly join to the session, Appa. আচ্ছা লুকমান আপনাকে কিছু জিজ্ঞেস করতে যাচ্ছে লুকমান wants to know something from you. Okay, you are okay.
Good.
Hi, Afrin.
My screen was not being shared.
Okay.
Okay.
No problem. No problem, Afrin.
I start sharing the
Slide.
background now?
Not yet, I think.
Or we try first the slide?
Can I try the clapping sound for the winner later?
Yeah.
Okay, sure. Hold on.
1% video recording has been sent, so that one without any noise, we have to check that. The recording is clear?
Recording clear.
Recording clear, okay, no problem.
Oh, one thing, Dr. Zaira, we cannot actually pop the question here, like stage.
Okay.
So we have to read from the Q&A.
Okay, Q&A box. We will go to the Q&A box and read the questions, no problem.
Hold on, I'll stop sharing. Okay, just a bit. Stop.
So in the poll, I will not create anything. Just put the feedback form.
Yeah, I think that is. Okay, can you hear this if I play it like this? Hold on. Do you hear it? Do you hear any sound? No, Afrin?
No.
No sound. Okay, then I'll have to play it by my phone. Can you hear it, or is it not clear?
It's very far from far.
Okay, hold on.
Yeah, nice.
Okay. So I have to do that since it doesn't work via the computer. So I'll do that. Okay, let's test because we have to play one pre-recorded video. Let's just test that one for Mudrika, I think.
Yes, yes. Better we do that.
Okay, we'll just test that for a while. Okay, I'm gonna share my screen. I'm gonna go to pre-record for Mudrika. Is it in full screen?
Yes, full screen.
Everything okay?
Okay.
Because
Sound is not there.
sound is not there.
Still, it looks mute.
Hold on. Okay. No sound at all, or does it sound very far?
Your
apart?
screen shows it has mute.
Oh, it has mute. But it's not muted. Can I see? No, it's not muted. Let's try again.
I think your computer system device is off here. You are using microphone?
Maybe I need to take off my earphone.
Try. Yeah, the sound is there.
The sound is there. Is it clear?
Yes, clear.
So it's very clear?
Yeah.
Okay, good. So that means just remind me I need to take off my earphone once I play the pre-record. Can you guys still hear my voice if I don't speak without any earphone?
Yes, can
Yeah, can. Clear.
Okay, that's good. So that means I won't use earphone. Make it easier.
I think our invited speaker, Dr. Asmalina, already there.
Yep.
Assalamualaikum, Doctor.
Assalamualaikum.
Welcome to you all. Actually, there is another 3 speaker. So we are waiting for them. Is it they have arrived already? Speaker and the evaluator also. I think within 5 minutes they will arrive, right?
Yeah, should be because it starts at 3:40.
Yeah, we will start at 3:40.
Can I try to share?
Sure, doctor. Go ahead, doctor.
All right. Okay. Is it already
Yeah, we can see, but it's not in full screen yet.
okay? I will try to use PDF because I'm worried that if I use PowerPoint, then it might be a bit heavy, and then it might have a problem later on.
Okay, sure.
Okay. Now it's a black screen, right?
Partial black on my side at least. I can see half of your PDF.
Okay, still loading. That's make me worry.
It's okay, doctor. It's okay. Hello, Mr. Shafiq.
Hello, good evening.
Good evening.
Hello, everyone. Yeah, now we are waiting. Mr. Shafiq is also with us. Now we are waiting for Miss Mudrika, and then she has given us the video recording. And then Mr. Taib. Mr. Taib is not there.
Yes.
Okay, now you guys can see clearly, right?
Yes.
Yeah.
The slide?
Okay. Full thing.
Hopefully after this is okay.
All right.
Okay. All right.
Okay.
So now stop sharing already. Is it still appear there?
Your slide? No, doctor.
Not anymore.
I think you stopped sharing.
Okay. All right.
So, Lukman,
Yes, Afrin.
in poll, we cannot post the feedback form. Maybe also in the chat.
It's okay. We can just remind them to go to the event and then at the end of the day and then fill up the form. Because I think the form that you're talking about is pinned
Yes,
there as
yes,
well,
yes,
right?
yes, yes.
So you just
Feedback
remind
That
them.
one I think it will be in the chat, right? The feedback form will be in the chat. Our
Yes.
evaluator, one of our evaluator has arrived.
Yeah, Dr. Stephen.
Dr. Stephen, yeah. Good afternoon, Dr. Stephen.
Hi, Doctor. Doctor, if you want, you can request if you want.
Yeah, I can request. Actually, Afrin, kindly please message to Dr. Suresh again. Actually, he
Remind Mr.
knows.
Saib.
He knows. He said he will join.
Yeah, actually, I talked with him also, Dr. Suresh Sagadevan, because we cannot start without him. I mean, all of us should be present there. We are waiting for Mr. Saeed.
Yeah, I'm reminding him.
He's from Islamic University, IIUM, Center of Foundation Studies. We will be just starting.
Okay, Doctor.
Actually, I am asking my moderator, should we start or wait for Mr. Taib to arrive and then start? It is 3:41.
If you really want to save time, Mr. Shafiq, our first presenter, is here. So we
So we
could
can
start
start.
with,
Okay.
as long as Mr. Shafiq is okay with it.
I think okay. So before starting,
Yeah.
we are beginning our session. This is session 1 based on nano materials and nanocrystal. This is Dr. Zaira Zaman Choudhury. I am senior lecturer from Nanotechnology and Catalysis Research Center. Today I will be session chair for this session. And this session, there will be total 4 presentation. 2 of them are invited speaker, our honorable invited speaker, and 2 of them are presenter. So we will be starting very soon. Before starting, if you have any question, please ask to our resource personnel or IT people, and you can move to the reception desk. And I would like to seek your kind cooperation so that there might not be any virtual disturbance during broadcasting the session. So welcome to you all. A very good afternoon and assalamu alaikum. Let us begin our session. Bismillahir Rahmanir Rahim. Let us begin it. Now we see here with me there will be 2 moderators, Ms. Afrin Jahan and Mr. Lukman Hashim. Both of them will be helping us. We will have 2 evaluators. The session, there will be 4 presentation as I mentioned earlier. So not the invited speech, the other 2 other 2 lecture will be evaluated by our honorable evaluator, Dr. Stephen Lai and Associate Professor, Dr. Suresh Sagadevan. And I myself also will be evaluating, and we will put our remarks and everything to our moderators. At the end of this session, the best presenter award will be given for this session, and this will be certificate. For the overall program, there will be best presenter, and for the overall program, the best presenter will be given certain amount of money ranging from 500 ringgit to 1000 ringgit. There will be trophy and certificate also. So that one, end of the program, we will tell. This will be 2 category of our award. So if there is any question answer for each of the presentation, please kindly go to the Q&A section and ask your question after the presentation is finished. And the presenter will be given 15 minutes for presentation and 5 minutes for question answer. But the invited speaker will be allocated slightly more time, that is 25 minutes for presentation and 5 minutes for question answer. Before finishing the presentation, the time is finishing, that moment, 2 minutes before, we will remind our presenter. And if the presentation go beyond the 5 minutes, exceeded 5 minutes, that moment, we have to unfortunately stop them because we have to be with time. Okay. So I think we can start our session. But before that, I think we have to take a photo. But I am afraid that we are waiting for one of our presenter. I think didn't arrive. I can see here we got Mr. Noor Shafiq and Miss Mudrika will be presenting. She has sent the video presentation. Dr. Asmalina is present with us, but Mr. Taib is not present until now. But we have sent them the message. So for the photo session, should we wait or we start the presentation? And in the middle of the presentation, after finishing one presentation, when everybody else arrives, then we go for the photo session. What do you suggest? I am asking my moderator.
Yes, doctor, we can start with the first presentation.
Yes, definitely.
I think we better start with our first presentation. I am very excited to start this presentation also because all the presentation I have seen the title. I think I myself also can learn lot of things from here. It will be very much interactive session and very important topic also. So let us first begin with Mr. Muhammad Noor Shafiq from University Malaya. His topic is fabrication and characterization of single and bimetallic nanoparticles. The stage is yours. Let us welcome Mr. Muhammad Noor Shafiq.
Hello, good evening all. Yeah, so I'm Muhammad Shafiq from University of Malaya. So can I share my screen first?
Yes, please.
So can you guys see my screen, my slides?
Yes, we can see your slides.
Okay, sure. So may I start now?
Yes, please.
So good evening to all the speakers and also the panels. So for today, I'm going to present my experiments on fabrication and characterization of gold and silver based single and bimetallic nanoparticles. So I am Muhammad Noor Shafiq Ismail from PRC, under Faculty of Institute of Advanced Studies, University of Malaya. So the content of my presentation today is about theory, and then I will go towards methodology, then results, and lastly I will go for discussion and conclusions. So in the part one, I will talk about the theory. So basically in the experiments, I was really into mid scattering theory, where light matter interaction is very important in this kind of phenomena. So basically what I see light matter interaction is follows mid theory, which is when there is a electromagnets wave incident into a particles, in a nano or micrometers range. So they will have a scattering there. So this incident light will have lasting due to absorption by the material itself and also due to scattering. So the scattering effects is affected dependently on particle size, which is the particle size must not exceed there is a particle constant there, particle size constant there from the theory. So it must not consider, because if it constitute the particle size, then there is an intramolecular interference happen, so that it will like diminish the intensity of the scattering itself, and then the refractive index of the surrounding, because it can alter the hotspot and also the interparticle spacing. So basically, if the particles is like very far apart, then we need to use a far field approach instead of near field approach. Then we need to use a far field approach like that. Next, due to that light matter interactions, so when light interact with a matter, then it will produce a polariton. It will introduce a polariton in that particles. So the oscillation of that polariton will specifically introduce a resonance called surface plasma resonance, which is called SPR. So this SPR is the oscillation of the polariton itself, and then this is the oscillation peak of that particular materials. So the optimum SPR, the SPR peak is very optimum at a specific plasmon behavior, which is the plasmon behavior we are considering about, like I said just now, the particle size, the Ri around surrounding, and also the interparticle spacing. So basically in the last previous study, the surrounding Ri and the particle size really affects the hotspot production. Hotspot is the place where most of the electrons are like really coagulate together. and that is the part where the electromagnetic wave can be resonance throughout the materials. So surrounding Ri and particle size is very affects the hot electron produced. Next, I will go into methodology. So it's in my part, I got four kind of methodology. I mean 4 steps. So the first step is about the fabrication of AU and AG. So basically in fabrication of AU and AG, I was talking about the fabrication of thin film first, right? So I was talking about fabrication of thin film first. The technique I use is E-beam evaporation techniques. So the material I use in this experiment is AU and AG, and then I deposit on 2 substrates, which is silicon and glass. So basically, the different substrates depends on the calculation that I was gonna use after this. Because as I use for FISM and glass for UVVs, and then I just deposit it with different deposition thickness. Then after I get the thin film itself, then I will go to the formation of nanoparticles using annealing process. So the annealing process takes for 1 minute of each thin film. So the temperature for it is 600 degrees Celsius for gold and 500 degrees Celsius for AG. Right. Then after that, the nanoparticles can be produced from the thin films. Next, I will do a characterization. So my characterizations right now just have a 2. So the first is as a phase morphology and topography only, using a FISM, and next I use EDX to confirm the elemental analysis to see whether if my thin film got extra, impurities like that. Yeah, and then I use UVVs to confirm, to see the SPR peak of my thin films, of every thin films. So the range of wavelength that I use in UVVs is 300 to 750 because my interested SPR peak is within that, or the interested peak of AU and AG. Next, after the experiments, I was using FDTD, finite domain time dependent software, to simulate my particles. So in this case, I used two kind of phenomena, which is the SPR, or the resonance in a single particle only, and then the resonance on V particles. I mean AU, AG, and also AU, AG like that. Next, I will present my results. So this is my experimental results. So the left part is the AU nanoparticles. So we can see that I deposit of 6 nanometer of deposition thickness. I mean during the E-beam, I control the thickness using quartz in that chamber. So for AU, I use 6 nanometer of deposition thickness and 8 nanometers. And then below that, we can see the particle distribution. This one I plot using ImageJ, solution, and then I have a UV spectra. So basically, if you can see that my particle size or my particle distribution is not uniform, so that we can see that the UV spectra, and also we can say that the SPR spectra is not distinguished between each other like that. It doesn't have very distinguishable two peaks like that. So for AG also same, but for AG I use 2 different deposition thickness. So for AG I use 8 nanometer and then 10 nanometer deposition thickness. So also I got still got a non-uniform. So basically this non-uniform mainly on my I think annealing process, yeah. And then also the UV spectra also show the same SPR peak. And the left side is my bimetallic. So this side is about for bimetallic. So bimetallic, I use 2 kind of combinations. First is AU6 and AG nano, AG8, AU6 and AG8. The other one is AU8 and AG10. So basically in this case, I just also plotting the particle distribution size and see whether I got another kind of peak, or I got a broader peak like that. Compared to the single peak. So basically, this is my particle summary of AU8 and AG10. So I do is using ImageJ solutions, but I do it manually. So I just getting all of the particle distance and also the diameter manually, and then I get the mean diameter. So for simulation, I use simulation for, like I said just now, single and also dual particle. So basically, for single particle, I use 16 nanometer diameter, and for dual particle, still same diameter, but then 100 nanometer of separation. Okay, so this one for AU, this one for AU, this one for AG, and this one for bimetallic. So I will go into discussion and also the conclusion of my results. So basically, for my experiment was what I was expecting is about the single and bimetallics behavior. So basically for single, if single nanoparticles for AU, the peak is about 5 to 0 like that. And then for AG, as we can see that the peak is around 450 nanometer. But for AU AG, we can see that the peak is quite broader. The peak is broader. So we can say that the peak is around 480 like that. But then the peak itself is broader compared to the single nanoparticle. So from there, we can say that there is a minimal interference effect occur between the AU and AG nanoparticles within the samples. So for simulation part, I was really into the effects of the particle size. That's why I was plotting three different particle size, three different particle diameter. So for AU and AG, I use for 20, 30, and 40 nanometer of particle diameters. So from there, we can see that there is a red shifting there. So the bigger the particle is, so the shifting will be to the to the right. All right, because the bigger the particle is, then the SPR also will change, because the bigger the particles, the dielectric constant also will change. So basically, it will change the hotspot and all of that. That's why it got a red shift. So until there is a limit, okay, where the SPR cannot occur, there is a limit of particle size. So, but then this one, the particle effects, I just plot for particle resonance of single particle resonance only. So next, I was plotting on the effect of dual particle spacing. So basically on this, I was plotting a single particles and also a dual particles. Like two particles there. So still I use 16 nanometer for AG and 16 nanometer for AG, but then we got two AG here, 16 nanometer, and then 100 nanometer separation. So basically, the peak is quite different. For dual particle, as you can see, the peak is around 520, while for single particle around 500. All right. So this is rise due to scattering effect. So basically, there is a scattering effect for dual particles. Then this one also shift the hotspot due to the alternate of the dielectric effect, and also shift the SPR peak. And then for experiment with the simulation, I was just showing that my experiments and my simulation. So basically, there is like a different peak for experiment simulation. This one is due to the non-uniform size of experiments, because as I can say just now, the experiments is not the particle is not uniform at all. So the shifting of the hotspot and SPR peak really give a great impact on simulation and experiment. So that's all from me. Thank you.
Thanks a lot, Mr. Shafiq. Very in-depth full presentation and very nice results. Now the floor is open for question answer. The participant can ask their question answer in the QA session. Any question answer? We are waiting for the question answer for Mr. We can go to the QA session. Yeah. Okay. May I ask the question? Actually, Dr. Chin Wai Lai has asked the question. What is the overall study aim of this research? What are potential applications for this sample, Mr. Shafiq?
Okay. So basically, the samples, this nanoparticle itself is about the sensing applications. There's a lot of, my PhD project is there's a lot of applications that I want to try to One of them is about the sensing of heavy metal ion things. So, but then it's not the nanoparticle itself. I need to like integrate it with 2D like that, 2D materials, and then also do some functionalization, and then I can get. So I use single and bimetallic to see the difference between single and bimetallic nanoparticles enhancement on the 2D materials for light trapping mechanism and also for the sensing applications. Yeah.
Another question: what is the overall study aim of this one? What are potential application of these samples? Sorry, this one we have asked already. It is from Dr. Lai. So we came to our next question from Associate Professor Dr. Suresh Sagadevan. How to control the particle size? How did you prepare the sample, and how did you confirm the purity of silver and AU nanoparticles? Have you studied XRD and FTIR?
Okay. So basically, for the particle size, there is a lot of methodology that I need to control. Some of it is about the thickness itself, the thickness of the position, and then also the annealing process itself. So annealing process, I got to like variety, the temperature, as well as the time of annealing. So basically, that is where I was gonna to alter to various my particle size, because I need to find the optimum particle size like that. So basically, to control it, I need to find the best recipe. So the best recipe depends on the thickness of the deposition, as well as the annealing time and also annealing temperature. And then for the purity, for now I just using EDX. So yeah, I know that I need to know another SRD, and also if they are. So basically SRD, they want for another application because SRD is about the crystalline structure. So yeah, I will doing it. Before this, after this, sorry, I will do it after this, and also if they are also to find the purity, to find the best purity of my nanoparticles. So by so far, I just use EDX analysis only to find is there any like a very specific or very common or very high heavy metal impurities. So for SRD and FTI, yeah, I will do it later.
Okay, understood. Very nice explanation. Is there any other question answer from the floor? We are inviting question answer. Is it okay? Then we can move to our next presentation. Is it okay? I think no question answer. So before going to our next presenter, I would like to thank Mr. Muhammad Shafiq for his nice presentation. Thank you,
Thank you
Mr.
so
Shafiq,
much.
for your nice
Thank you so much,
presentation.
doctor. Thank
Stay
you.
safe, stay healthy, and stay with us because we have other 3 nice presentation. Okay,
Okay,
please join with us. And now I will request all of our participants here in session 1, nanocrystals and nanoparticles, kindly turn on your camera so that our IT personnel can take a photo. Please kindly turn on your camera. Thanks a lot. Let us take a photo. It will be a nice memory.
Okay, sure. Dr. Steven, would you like to join?
Okay. Is it okay, Dr. Steven?
Yeah, he's in.
Oh, okay, just coming. Yeah. Oh, okay, okay. Very nice to see you all. Thanks a lot for joining. Let us take the photo.
All right. It's just print screen. 1, 2, 3. And one more. Okay. Thank you.
Thank
From
you.
me. Afrin, do you
Thank
need
you
to
so
take
much.
anything more? Okay, Afrin done.
Let us move to our next presentation. Our next presenter is Miss Mudrika Sophia. Her topic is size reduction via ball milling and acid leaching effect on rice husk ash derived nanosilica. She is from IIUM, Department of Manufacturing and Metal Engineering. Let us hear from her.
Okay, I will be sharing her pre-recorded video. So bear with me for a bit. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mudrika Sofiamti Mahmud and today I will present to you about my project entitled Such Reduction via Ball Milling and Acid Leaching Effect on Rasas Derived Nanosilica. And this is my presentation outline. And for the introduction, as we know, Rasas ash or RHA is a product from the burning process of rice hulls, and it could be considered as one of the excellent sources to synthesis of silica. With proper burning condition, RHA with a high percentage of silica could be obtained. However, this high percentage of silica commonly comes together with high percentage of other impurities. These impurities could be reduced through several treatments, and it has been reported that these impurities had been significantly reduced by the combination of acid leaching and thermal treatment. And previously, acid leaching had been done at temperature up to 100 Celsius in order to remove the impurities.
Sorry. Oops.
However, the process of boiling this acidic solution is quite risky, which requires extra precaution and also it is a bit time consuming. On the other hand, currently the production of nanosafe material is in high demand, and by doing the modification in particle size, such as alter the particle size in nanoscale, it could create higher surface area, which later will lead to higher reactivity during reaction, and thus superior performance could be expected. And with that, nanosilica could be obtained from RHA through several methods of preparation, and one of them is through precipitation method. And by adding acid in a dropwise manner into sodium silicate solution while stirring, the precipitation of silica particles in nanosafe could be expected. And previously, it has been reported that through precipitation method, high purity silica particles and also high purity silica particles with average particle size which is less than 100 nanometer could be obtained. So the main objective in this project is to synthesize nanosilica from RHA through precipitation method. At the same time, this project wants to compare the properties of the resultant silica powders, since two different sizes of RHA have been used as a raw material in the synthesizing process. And concurrently, this project also wants to compare the silica yield of the treated RHA in order to highlight at which temperature of acid leaching treatment which yield higher silica percentage. So the materials that have been used in this project is rice husk, hydrochloric acid solution, sodium hydroxide pellets, sulfuric acid solution, and also distilled water. And for the sample preparation, this project started with the preparation of RHA. After the burning process, the RHA obtained is collected and has been divided into two parts, and one part is termed as original RHA, in which this RHA is used without any modification. Meanwhile, the other one is termed as ball mill RHA, at which this RHA had been physically altered through ball milling process at 500 rpm for 10 seconds. Next, the prepared RHA is collected and proceeded to treatment of acid leaching and thermal treatment. For acid leaching treatment of original RHA, it has been done at two different temperatures, such as at room temperature and at 80 Celsius. Meanwhile, for ball mill RHA, the acid leaching will be done according to the leaching result of original RHA, at which temperature resulted in higher percentage of silica. And then this treated RHA were collected and proceed to the precipitation method in order to synthesize nanosilica. After the silica powder has been obtained, the powder is collected and proceed to the specified characterization method. The characterization for the prepared powders have been summarized in this table, and the properties of the prepared powder have been examined through XRF, EDX, FTIR, XRD, and FSM. For the XRF analysis of the acid leaching treatment, from the result obtained, we could observe that initially or before the acid leaching treatment, RHA contained high percentage of silica, however, together with high percentage of other impurities. And regardless of the temperature, after the leaching treatment, the presence of these impurities been, had been significantly reduced, and the amount of silica had increased about 9%. And from this result, it can be concluded that acid leaching treatment with hydrochloric acid solution is one of the efficient treatment in order to reduce the impurities present in RHA. And in order to compare the silica yield from the treated ash that had been done at two different temperatures, first at room temperature and second one is at 80 Celsius, the resulted silica yield show that the treated ash contain about the same percentage of silica. So acid leaching treatment is more preferred to be done at room temperature since it is much simpler, safer and easier. And according to this result, the acid leaching treatment for bone meal RHA had been done at room temperature. And for XRF analysis of the synthesized powder, the result obtained show that the synthesized powders contain high percentage of silica up to 99.7% with no detection of other impurities. So this result suggests that high percentage of silica, which is expected to be in nano size, could be synthesized from RHA through precipitation method. For the elemental composition and purity of the synthesized powder, according to the EDX spectra obtained, this spectra indicates the detection of two characteristic peaks that belong to oxygen and silicon element, which confirms the presence of silica in the synthesized powder. And from the detection of these elements, the main bonding in silica, which are selenol group and also siloxane bonds, could be expected. And the expected main bonding in silica were clearly observed in figure 2, which show the FTIR spectra of the synthesized powder. And these two spectra had show the detection of identical peak in the range of wave number from 1100 to 400, which indicate the fingerprint of silica. And from these two spectra, EDX spectra and also the FTIR spectra, show no detection of other peaks, and this implies that silica in the synthesized powders is obtained in high purity. For the XRD analysis of the synthesized powders, the XRD pattern obtained show the formation of broad and wide peak in the range of 15 to 35, with center about 2 theta equal to 22, which again confirm the formation of silica, and with no detection of any sharp peak. This result confirm that these prepared powders contain silica particle in amorphous structure. For the morphological characteristic of the synthesized powder, according to the FSM micrograph obtained, the result indicate that the synthesized powder contains silica particles in the form of spherical shape, in which they are agglomerated with each other and form a highly porous structure. And this micrograph also confirms that silica in nano size has been successfully synthesized from RHA. And in order to compare the resulted silica particle size that has been synthesized from two different sizes of RHA, the particle size has been measured manually through this FSM analysis, and the resulted measurement are as follows. And from this result, it could be said that the utilization of different size of RHA in the early stage of a synthesizing process has resulted in insignificant difference in particle size. So from this result, it could be conclude that the physical alteration of RHA as a raw material in the early stage may not have a significant role on producing smaller nano-sized silica particles. And also from this FSM analysis, it can be concluded that nanosilica powder has been successfully synthesized from precipitation method. So for the conclusion, the finding from this project show that the combination of acid and thermal treatment has successfully minimized the presence of impurities in RHA. And for acid leaching treatment, the process of leaching at two different temperatures had resulted in insignificant percentage of silica. Hence, acid leaching at room temperature might be an optimum procedure in order to obtain high percentage of silica since it is much simpler, easier and safer. And for the synthesized silica powder, the silica powder has been successfully synthesized from precipitation method, and the powders contain high purity silica particles which has amorphous structure, and the most important, it is in nano size. It obtained in nano size. Meanwhile, for the physical alteration of RHA at the early stage of synthesizing process, it has resulted in insignificant difference of nanosilica particle size. Hence, it could be concluded that the physical alteration of RHA in the early stage may not have a significant role on producing smaller nano size. And this is the list of references in my project. And that's all for me. Thank you.
Thanks a lot, Miss Mudrika. It was a very nice and clear presentation. Actually, now I am opening the floor for question answer. Let us see. It is very interesting what Ms. Mudrika. Can this acid leaching be replaced by organic acid? Afrinjan, from Afrinjan, this question came. Could you please answer? You are
Okay.
here.
Assalamualaikum. Uh, as far as I know, the acid for acid leaching, there's previous study that use low concentration acid, I mean weak acid. However, the leaching process is not very what we say that not all the metallic impurities had been reduced because some metallic ions is not attracted to the acid to form salt, and however for organic acid I'm not very sure.
Actually, I think organic acid will be less performance. There is another reason for less performance because there will be less number of H plus, and that is the thing, because the organic acid will be dissociated less, right? It is weak acid, so maybe for this one. But one positive thing is organic acid will not destroy the surface of your silica. But if the inorganic acid have high concentration, one you are using, then it might destroy the porosity or the surface of the silica. It depends up to which extent you have concentrated it. Okay. Okay. Let us go for our next question from Dr. Blai. Did you publish any ISI paper from this research?
From this research, not yet. Maybe soon.
Any other question from our panel or evaluating panel, from our evaluating panel or our participant? Any other question?
So how to avoid?
Doctor, there's a question in chat.
Oh, okay. Oh, there is a question in chat. Okay, it didn't come to the question. To the invite, very nice lecture. Can you please advise about how to avoid aggregation or agglomeration after the milling process?
After the milling process, maybe one of the way that we can do is by using sonication. Sonication for about 1 hour, because I have read that sonication in 1 hour resulted in better FSM result. I think.
Okay. Another question from Dr. Suresh Sagadevan. What about the surface area and porosity of the nanosilica? What about the crystalline size of the prepared sample?
What about the crystal size of the? What about the surface area and? Oh, for that characterization, I'm not done yet because my project focus on the preparing the nanosilica first, and for the future works, maybe we can look into the surface area and also the porosity of the nanosilica.
Any other question from the participant, the panel? I think it is okay now. I think there is no question. Thanks a lot. Thanks a lot, Ms. Mudrika. Now maybe we can
Thank
move to our
you.
next invited speaker, Dr. Asmalina Mohammad Saad from UNIKL. Our invited speaker will be given speech on the effectiveness of nanoparticle and natural antifouling additives, a comparison of seawater immersion. Let us hear from her. Thank you, Doctor. The floor is yours. Please unmute yourself, Dr. Asmalina. Kindly unmute yourself. Is it okay? Dr. Asmalina can share the screen. Maybe Mr. Lukman and Ms. Safrin can help, please.
Okay, hello, doctor. First of all, can you please unmute on the screen, the mic? Sorry, doctor, I still can't hear you despite you using your mic. Can hold on. Okay, because it says here you're still muted, doctor. So let's see. I'll share my screen and then we'll go from there. Okay, doctor. Can you please click on this button first, and we'll see if it's still you still can't hear you. This button right here, this little mic button here. Did she type anything? The mic button here. Can you see on the bottom there? Okay, I'm assuming you have trouble with your mic. Can you type it? Okay, I think we can hear you now, doctor.
All right. Okay. I don't know what happened. All of a
Okay.
sudden it become hang. Okay. I try to share my screen right now. Okay.
Okay, no problem, doctor. Take your time. Don't worry.
All right. Okay. Can you guys see this the screen right now?
Give it a minute. Yes, we can see it now.
All right. Okay. Great. All right. Okay. I'm now entering the full mode. Okay. Is it a black screen or is it already full screen?
I think it's going to full screen. It's a bit lagging because we have the document. So
Okay.
need a few more seconds. We'll see.
All right. Hopefully it will appear after this. Oh, okay.
Okay, now it's in full screen.
Okay, wait for a while. Okay. Bismillahirrahmanirrahim. Okay, Assalamualaikum and a very good day everyone. Okay, I am Asmalina binti Muhammad Saad from Unique Almi Med. Okay, I am very pleased to share our research today. Okay, which the title is the effectiveness of nanoparticles and natural antifouling additive. Okay, a comparison of seawater immersion. Okay, I would like to appreciate my teammate, okay, my research mate here, which they contribute a lot in the successful of this research. Okay. All right, so this is the outline of the content that we will discuss after this, okay, which is we will discuss to the abstracts, introduction, methodology, result and discussion, conclusion, references, and also the Q&A. Okay, so for your information, this is my campus, which is the University Kuala Lumpur, Malaysian Institute of Marine Engineering Technology, or also known as Unique Almi Med. Okay, which it is located in Lumut, Perak. And as what you can see here we have our own shipyard here, which is we have also our own slipway. So this is the position where we do the immersion testing directly. And here nearby is a marine related industry, which is it also help our students to learn more about the marine industry. All right, so basically this is the one that we will cover later on in this research. Okay, we will discuss about basically the problem about the biofouling. Okay, which this biofouling, for example, as we can see in the picture here. Okay, this is the difference between we apply the anti-fouling coating and without the application of the anti-fouling coating. So biofouling is a marine growth, which this marine growth will affect the hydrodynamic efficiency, and this will lead to the decrease of the drag. Okay, we increase the drag of the ship, and thus it will also increase the fuel consumption, and then it later will also lead to the increase of the fuel costs and also operation costs. Okay, and then it's a case worst case scenario. Okay, this marine growth also will lead to the corrosion problem after it's washed away from the surface. Okay. So in our case here, we focus on the application of nanoparticles together in comparison with the natural antifouling, okay, which we focus on the coating application. Okay, previously, antifouling additive that well known being used, and it is a very efficient and effective, which is known as a tributylene or TBT. But this one already been banned by the IMO. IMO is the International Maritime Organization. Okay, in 2008. Okay, earlier this afternoon we heard about the nanotechnology in Malaysia, right? Okay, the bodies that controls the nanotechnology. But this one is international bodies that controls all marine related application. Okay, so here including about the coating. Okay, there are also IMO that give us a guideline. Okay, what's the amount of element that can be added in the coating. So most of the researchers usually they focus to do the laboratory assessment, which is related to the physical, chemical, biological, mechanical, and also the corrosion properties of the coating, which is EIS, LR, and so on. Okay, however, as what you can see that the real problem in the coating, okay, basically if we want to produce composition of coating, okay, it cannot be applied in various location, okay, due to the different of the composition of seawater. Okay, so here there's a less number of research that focus on the actual seawater immersion, especially for both application of nanoparticles and also natural antifouling. So in this research, okay, we choose two type of nanoparticle, which is a zinc oxide and also silica dioxide nanoparticles, and also the natural type of antifouling, which is aloe vera and also charcoal. Okay, additive that being used to immerse in a lumut seawater. So we take about 6 months, because most of the journal they do about only 3 months, so which is less duration of immersion. So here we focus about 6 months of immersion. Then we evaluate the performance of the coating, and then both of these nanoparticles and also natural antifouling shows a good antifouling properties, which we observe that 10% of silica nanoparticles shows an optimum performance in the evaluation of a percentage of thickness change, in a marine growth change, weight change, and also in a corrosion rate. Okay, and it also follow almost a similar finding with silica nanoparticles, that in natural type of antifouling is 10% of aloe vera. Okay, now we move forward to the introduction of parts of ship. So this is a ship parts, as what you can see that this is a parts that we can divide on ship. That in ship here we have an above waterline and also below waterline. At the above waterline, if you notice here, most of the ship have a different color. So for above waterline, usually we have the type of paint that anti-corrosion, but the below waterline usually we can see that it is in a red color. It is a anti-fouling type of paint. Okay, so that's the difference between these two type of paint. Okay, so in a marine coating, it can be either anti-corrosion or anti-fouling type of paint. Okay, so in the case of anti-fouling coating, usually it is also known as underwater hull paint, which it been used to protect and slowing down the marine growth, on that ship hull. This is we call a ship hull. Okay, so the main structure of a ship body. Okay, so in a marine growth, there are two types of marine growth. It can be either plant growth or also animal growth. So in the plant growth, I think you guys are already familiar. You can observe it as a slime and algae, for example. And in the animal type, you can observe it as a very hard shell, as a barnacle, for example. Okay, which it can attach usually at the below water line or at the ship bottom hull. Okay. And then here, the microorganism, as I mentioned earlier, it will affect the performance and endurance of the vessels, and which it will reduce about 80% of the speed of that vessel. So it will also leads to the high fuel consumption here. Okay, as what you can see here, it's got for this type of ship, both to DD751. Okay, so when it involves a repainting, for example, recleaning, although it just only have a heavy slime, and it's not a barnacle, so it's not a hard type of marine growth. Okay, it will also need about 56 million per annum. Okay, per annum. So this ship usually for steel hull, it will increase cost due to the frequent of dry docking needed. So when we need to remove the slime, okay, of course we need to put it in dry docking and then remove it. Okay, so this is the cost that we must use in order to remove it. Okay, other than that, okay, in for the calcareous falling or for the hard shell type, it will give a power penalties about 85%. It reduce the powers about 85%. For slime, okay, for slime is about 20%, which is quite high, although it is a slime. Okay. But of course, we don't want this type of plant type. Okay, sorry, animal type. All right. So most of the research stated that 70 to 80% of invasive aquatic species interaction occur through ship hull biofouling. So most of the drag or most of the power consumption is come from the hull because it's a major parts in the ship. Okay, so this is the history of this anti-fouling. So anti-fouling basically it been used as early as 300 before century, which they use a lead and copper that been applied on the wooden boats in order to prevent a marine growth. Okay, however, as the time continues, then they found that TBT or tributylene is very effective to prevent a marine growth. Okay, then within 2008, okay, IMO banned the TBT usage in the paint due to the abnormal growth on the oyster shell. Okay, so this is due to the toxicity that contribute by this TBT. And in 2018, it totally been banned. Okay, in the paint in the marine paint. Okay, in the marine paint industry for marine application. So this one continuously been monitored by this IMO. Okay, and then so most contemporary of anti-fouling coating. Okay, we look for this non-polluting of AF, so less toxic, and then we need to it to degrade rapidly. So if degrade rapidly mean that it is a self-cleaning, okay, self-cleaning of type of marine paint. Okay, this is a picture that we can observe a very heavy. Sorry, we have I missed this one. Okay, as we can see here, okay, is as early as 1 hour is already have a diatom that attached to the surface, and then within 24 hours you can see that it already have those particles or those slime that may occur, the diatom of slime, and then it will continues to grow as early as 2 weeks. Okay, you can see that the slime, okay, occur clearly on the surface, okay, of that paint. And then there are two types. You can describe it as a microfouling and also macrofouling types. Okay. All right. So of course we cannot prevent it because it is a marine life that have in seawater. We have in seawater, so we can only slow it down. Okay, slow the process of the attachment of that marine growth. All right, and then here. So after the ban of the TBT, okay, we look for the anti-fouling coating that less toxic but effective. However, the challenge is that is due to the types of vessel. That means the operation profile, means that the speed, okay, the water, the location means the condition, the water condition. Okay, that this one also contribute to the challenge in the development of the anti-fouling coating. Okay, and then other than that, because of a different environment, we have a different composition of seawater. Then the interaction between the marine growth and the coated surface also still there's a lot of things that there's a lot of things that can be we can do research on it. Okay. So for the natural anti-fouling, we have observed that a number of natural sources such as seaweed, soft coral, sponge, mangrove, fish, algae, lemon, capsaicin been reported as a good natural resources anti-fouling additive. Okay, because of course it's non-toxic, eco-friendly, and do not contain heavy metals. Okay, for lemon, for example, they compare it with the pharmaceutical antibacterials, and it's proof that it can be used also in marine fields. Okay, but it's not suggest to apply on a steel, but it can apply on the composite surface or composite substrate or wood substrate. Okay, and then for aloe vera, for example, it been reported to be used as an edible coating and has a good UV properties. Okay, due to the good UV properties, it been said that it reduce the degradation of the coating, so it have a high stability, okay, of coating if we use this aloe vera. Okay, for charcoal, it also been reported that it have a conductive properties together with the hydrophobic properties. Okay, and it also shows a good corrosion resistant in acid solution for the laboratory assessment. And the contact angles that been measured is about 83.32 degrees. Okay, when an improvement if we compare with the uncoated metals. Okay, and then For the natural AF, basically, yes, okay, it said that it can helps to enhance the coating performance. Okay, however, there's a lot of things also that it can explore in order to get more knowledge of these natural sources being applied in this coating industry. Okay, so for nanoparticles, okay, silicon dioxide and zinc nanoparticles, okay, been chosen due to its good mechanical thermal properties, and it's called as a robust coating. Okay, so and these two type of nanoparticle also we observe that it produce a less toxicity value if compared as what been discussed earlier in our in the keynote speaker, which is titanium oxide and also silver nanoparticle also have a good antibacterial properties, but it have a high toxicity. So in this case, both of these have a less toxicity effect on the marine environment. Okay. But however, there's no research that shows about the actual immersion more than 3 months. Okay, and then the contact angle, which relate also to the surface roughness, also less that been reported here. Okay, and then there's also no data about those application of natural and additive and also nanoparticles in the Malaysian seawater. So this contribute to the Malaysian database also for the corrosion and coating application, coating performance. All right, and then here, okay, we have attention to do the immersion for 6 months. Okay, this is the methodology that we conduct in our process of research. First is the substrate application. We choose the substrate of my steel, is a marine grade my steel. Okay, with this cross area, and then we blast it into a surface profile SA 2.5, and then we apply a coating. This coating being combined with an epoxy base of paint. Then we stir it homogeneously. Then we apply it to the surface, okay, for a 3-layer coating. Okay, 3-layer coating according to the been suggested by the pen provider. And then this is the additive that been we put in the epoxy base pen, which is zinc and silicon dioxide nanoparticles for the nanoparticle base, and for the natural we use aloe vera and also charcoals. And immersion test, we follow the ASTM standard of 3626 for the submerged immersion test. And then characterization, we characterize the contact angle measurement, and then we evaluate it use image J software. And then we also evaluate the marine growth percentage, the weight change percentage. Another thing is that the thickness change that occur, and also the corrosion rate that occur in millimeter per year. Okay, this is the formula that we use in order to calculate the corrosion rate. And this is the process of preparing the my steel coupon, and then this is the position where we immerse the margin coupon. Okay. Okay, for our first result, okay, this is the result for the weight change. Okay, as what you can see that as the day of emission increase, okay, the weight change also increase. However, that we can see the bare metals here, okay, observe a highest change, highest weight change about 17.38%. Okay, meanwhile, for the silica nanoparticle, it observed the lowest value with a 0.21% of weight change. Okay, then for the 10% of weight aloe vera and also 10% of zinc oxide nanoparticle, it give a value of 0.43 and also 0.35% of weight change respectively, which is an acceptable value, the lowest value among the other sample. Okay, for the second result here, we have a percentage thickness change similar with weight change. Okay, when we have a increase in a day of immersion, it also observe an increase of the percentage thickness. Okay, you can see that here similar that aloe vera have a lowest value. Silica nanoparticle have a lowest value, which about 2.73, and the bare metals about 175% of thickness change. Is quite high there, but it followed by 5% of nanoparticles here due to the defect that occur on that coating. Okay, but here in 10% of nanoparticle, which it shows that it have a good performance of thickness change, which less value. Okay, followed by the aloe vera, which is about 3.1. Okay, 10% of aloe vera. All right, so next we move on. The third diagram here shows the percentage of marine growth where we do a mapping method there. Okay, we observe that, okay, the percentage of marine growth increase as the day emission of increase. As we can see that for the bare metal here, as early as 40 days, you can see that there's a large change of the marine growth. Okay, there's a lot of marine growth already occur here. Okay, here is already reached of 100% surface that been covered with the marine growth. Okay, however, for the other type of additive, okay, so it's about 100 this 150, then it start to occur a slime. But for the 5% of nanoparticle, silicon nanoparticle here, we can see that due to the defect that occur, then it start to have a dramatic change of the percentage marine growth here. Okay, so here we can see that for the 10% of silicon nanoparticle, it shows a good inhibition properties of marine growth, okay, followed by the 10% of aloe vera. Here is the observation, visual observation that we can observe on that my steel coupon. You can see that surface of the bare metal already been covered by hard type, okay, plant type of marine growth, but the others are all only covered by slime. But this one is for the 5% of silica. It already been part of that coupon, already been attached with animal type. Okay, animal type of marine growth. Okay, the others we can see that you can still have only plant type, which is in the form of slime. Okay, in the form of slime. For the charcoal, you can see that the difference between 5% and also 10%, the difference in color there. Okay, here 5% you can see, 10% you can see that it's much more darker color. But the rest, for example, when we use zinc, silica, aloe vera, it's just the same color as the base paint that we use, okay, which is a red color. Okay, this is not basically the day 0. This is initial, is about day 7. Okay, where we look on the change that occur on that marine coupon. So we can see that it's already attachment of slime basically for both sides of that surface. Okay, so this one is commercial AF, which we also compare it, okay, with the other additive that we use. You can see that in commercial antifouling, okay, there's also increase of those marine slime type of marine growth. Okay, so next we move forward to the this is the contact angle change. Okay, contact angle change, we can see that most of the contact angle decrease as the emission time increase. So for bare metal, we can see that down here this is 0. Okay, we cannot measure it because it's flat on that surface. We cannot get we cannot get the drop of that, the droplet, the water droplet on that bare metals. Okay, both silicon nanoparticle and aloe vera observe an increase in additive. Okay, ratio, it will increase the contact angles. For example, when you increase from 5 to 10 in silica nanoparticle and aloe vera additive, then we will see that the increase of a contact angle. But however, for the zinc nanoparticle and also charcoal, okay, when we increase the ratio from 5 to 10, we can see that there's a decrease of contact angle in this case. And for the final contact angles, 5% zinc shows the highest value of contact angle, about 86.63, okay, which followed by aloe vera, 10% aloe vera, then 10% charcoal and 10% silica with a value of 83.21, 80.95 and also 80.10 respectively. So we can see that the percentage, a higher percentage of this additive contribute a better value of contact angle. Okay. All right, so this is the visual observation of contact angles picture that been taken. You can see that the droplets of the water and the measurement we use that ImageJ software. All right, so next is the last result that I will share with you guys is about the corrosion rate. Okay, so the corrosion rate here, we can see that the uncoated or bare metals here is about 2.241, and then it is the highest one. And then here second highest is 5% of silica is due to the defect that occur and on that surface. Okay, on that film surface. Okay, you need to bear in mind, it's been suggested by the ASTM standard and also by the actual application, we should apply at least 2 layer of anti-fouling coating. But in our case, we only apply 1 layer. Okay, 1 layer, meaning that we have a primer, 2 layer, we have also tie coating, 1 layer, and then the last only 1 layer of anti-fouling. Okay, if we use 2 layer of anti-fouling, then the result will be better. Alright, you can see that for the 10 weight percent of silica, it produces the lowest value of corrosion rate, which is a very good value for anti-fouling coating. And then it followed by 10 weight percent of aloe vera, about 0.058 millimeter per year. Okay, so here, okay, we can conclude that the natural natural and also nanoparticle anti-fouling additive coating are successfully been prepared and immersed in seawater and evaluated. Okay, the immersion time increase. Okay, as the immersion time increase, the thickness, the weight change, the marine growth also increase. But however, the contact angle will decrease. Okay, in all sample, the contact angle decrease in all sample. Okay, in the nanoparticle additive, we can observe that 10 weight percent of silica nanoparticle shows an optimum performance compared to the other type of nanoparticles. When we look at the result of percentage thickness, marine growth, and also weight change and also corrosion rate. For the natural type additive of anti-fouling coating, then we can see that at 10 weight percent of aloe vera observe a good performance in all analysis. Thus, we can conclude that, in comparison with natural and nanoparticles, so nanoparticles of 10% of silica produce a better performance compared to the natural additive. However, this 10% of aloe vera also, 10% of aloe vera observe better stability. Okay, due to the contact angle performance that we observed just now. This one supported by the other researchers that we discussed earlier, that this aloe vera can produce a better stability in a condition due to its UV properties. Okay, for future recommendation, we can also do other testing. For example, in the application, it's very important to have an addition testing, so that we can see the effect of these nanoparticles on the addition strength of the coating. We can also do others of visual observation of the failure analysis for both additive nanoparticle and also the natural type. Okay, and then we are planning also to do the regression analysis, but for this sharing, we don't have time to do those finding and then to discuss this finding. But regression analysis also important, so that we can predict the behavior of that coating if we immerse it more than 6 months, maybe about 12 months or more than that. Okay, so that's all for my sharing today, and then thank you. Any question?
Thanks a lot, Dr. Asmalina. Very nice presentation. Is there any question answer? I will check in the QA box. Okay, we got it. From Miss Mimi Hani Abubakar. She's from University Kebangsaan, Malaysia. Our question is on the aloe vera. Did you use chemical or electrochemical method, or by physically rolling it onto the surface? Is it enough to save long-lasting effect on the surface?
Okay, maybe my lines have problem, cannot hear you clearly. But if I'm not mistaken, that the question asked whether I did the laboratory assessment. Am I right? The EIS and so on.
Yes. Either you have used chemical, electrochemical, or physical rolling method. Which one you have used and why?
Okay, for this method, we just directly immerse in seawater, because there's a lot of information about the EIS, the polarization and so on. Okay, we just add information, add new knowledge about the immersion in Malaysia seawater, because there's quite critical for us to get a database of the effect of coating in our Malaysian database. In our Malaysian seawater, there's no database on that one. So this the problem. Basically, we solve on the lack of information about Malaysian condition, the coating performance in Malaysian condition, Malaysian seawater. So no, the answer is no. There's no EIS and so on.
Okay, thank you, Doctor. Is there any other question from the participant or our evaluator? Any other question? Okay, is there any question? Okay. Another question from Ms. Afri Jahan. Which coating technique is applied here?
Coating technique. I think I mentioned it in the methodology. We just use because we are an applied university. We applied the current technique that been applied in industry. So most of the time they use a roller. Okay, so we use a roller, the simple one, not an advanced method. No, the simple one. Okay.
It's a very nice presentation. Thanks a lot, Doctor.
All right.
Thanks
Thank
a
you
lot
very
for your
much.
kind attendance. Take care and stay safe. I
Okay.
think it is time for us to go to our next presentation. Our next presenter is Mr. Taib. His topic is optical properties of silver silica nanocomposite thin film synthesized by a solgel technique at various volume ratio. He is from Center of Foundation Studies, IIM. Welcome, Mr. Taib.
The line is breaking, if I'm mistaken. Is it me only hearing breaking? Or
So far it's clear, Doctor. I think it's one of our participants. Mr. Taib, you can just try to proceed with the sharing screen.
all right?
I would request our participant to mute, okay, when Mr. Taib is presenting.
Yeah, sure.
Is anyone see my slide? Can you see my slide?
Not yet, Doctor. Not yet, Mr. Taib.
Okay, hold on. Right, so I have difficulties now. Hold on. Okay now. Right, so what about this one?
Yes, we can see it now.
All right, good. Okay, thank you very much, Dr. Zaira. Assalamualaikum and salam sejahtera and good afternoon to everyone. So we are now at the first Malaysian International Conference on Nanotechnology and Catalysis, a new dawn of innovation and technology. Is the slide moving?
Yes, it is.
So, this is me. My name is Taifun Isham Taib. Currently, I'm teaching at the Center for Foundation Studies, International Islamic University, Malaysia. And the title of my presentation is Optical Properties of Silver Silica Nanocomposite Thin Film Synthesized via Sol-Gel Technique at various volume ratio. And this is the abstract of my works. Basically, we have successfully synthesized the silver silica nanocomposite at various volume ratio. We synthesized about 5 samples of this silver silica nanocomposite. The only difference is that they are different in terms of the composition between the silver nanoparticles and the host matrix. And then we deposit this nanocomposite on the ITO substrate. ITO stands for indium tin oxide. And of course, after a few characterizations, we found out that the optical properties can be tuned according to the amount of silver that we put into the host matrix. So this is my presentation summary. Introduction, research, objective, methodology, results, discussion, and conclusion. So the first one, introduction. So this research or this work is merely inspired by the remarkable properties or optical properties of the silver nanoparticles. As we know that it has a very special characteristics based on the surface plasmon resonance or SPR. The reason behind this work is that in most of the studies conducted about how the silver nanoparticle randomly distributed in the host matrix, most of the research is based on theoretical. So a versatile, low-cost experimental method is yet obtaining a strong perceptions. Now, what makes the silver nanoparticles very attractive is that it is due to its good catalytic effect. It has very optical novel properties. It's good in electronic applications, and the material possess a good chemical stability and thermal conductivity, and also in application in the magnetic application. And the inset picture that you can see is well distributed of the silver nanoparticles with the average size of 20 to 50 nanometer. Now, if we zoom in every of these silver nanoparticles using ultra high vacuum scanning tunneling microscopics or UHV STM, we can see that the silver nanoparticle is actually a cluster of numbers of atoms. There's thousands of them, So the size of the silver nanoparticles depends on the numbers of atoms bind together inside this one cluster. So if you go to higher resolution, you can see that the numbers of atoms sometimes is thousands, 100,000s of atoms consists in the one cluster of 1 nanoparticles. Now, the surface plasmon resonance is referring to the excitations of free electron on the surface of the metal. Now, it creates a certain amount of field. Now, when this field interact with the propagated light, it will determine the magnitude of the polarization process, then which is the basis of the optical properties of the material in terms of to determine the permittivity, and then next is the refractive index of the material. Now, about the host metric that we use in this work, it is based on the tetraethyl autosilicate, which is the end product is silica, of course. We use this as the host metric because it has good thermal shock resistance, low refractive index, and high softening temperature. Now, from our finding, from the images shown in the transmission electron microscope or TEM in diagram B, you can see that. And then when you compare with the previous literature by Arun, 1996, now our host metric consists of amorphous structure and crystalline structure. Now, the study or the analysis of the characteristics both between the silver and silica is based on the Maxwell-Garnett mixing formula. That's why, as we know that silver has its own permittivity, and then silica has its own permittivity. So when we embedded the silver nanoparticle, so it produced a new optical properties, especially referring to the effective permittivity of the new material, which is the nanocomposite, which is specific, which is the silver silica nanocomposite. So we use this model to calculate the effective permittivity of this new material. So the research objective is to produce the silver nanoparticle according to our desired shape and size, because as we know that the surface plasmon resonance depends on these two properties. And also we synthesize the silver silica nanocomposites with a different volume ratio and characterized with several techniques. So this is the methodology for literature review. So we produce 5 samples of silver silica nanocomposite. The only thing different is that the amount of silver that we put into the host material. Now this is the process where we produce the silver nanoparticles. We start with the chemical reductions, of course, centrifuge, and then we put it under precipitations process, and then finally we obtain the silver nanoparticles, and then we convert it to the silver colloid for storage and further characterization process. So this is the table to summarize how it is conducted. So we have 5 samples. So the composition of the silver, you can see that according to the fractions on the right column, the first sample 0.2, then next 0.4 until 1.0. So this is how we produce the nanocomposites. We assist with the Catalysis solution, and then we put it under sonication for 45 minutes, and then we let it dry for 3 or 4 days. And then using mortar, we convert it into powder. So this is the sol gel techniques based on the chemical equation. You can see that from the TIOS with the presence of alcohol and water. So the final product is the silicic acid, or it is the other name for silica. And then with this final product from this hydrolysis of TIOS is combined with the silver nanoparticles. Then we produce the silver silica nanocomposites together with water. So after drying for 3 and 4 days, the water eventually evaporated. Next, we conducted the electrophoretic deposition process. As you know, at the left side is the experiment setup. At the middle is the solutions of between the nanocomposite powder and the propanol. And then on the right side of the picture, you can see that the nanocomposite is nicely deposited on the ITO substrate. So this is a schematic diagram of the electrodeposition process for synthesizing silver silica nanocomposite thin film on the ITO glass substrate. So as you see that the solutions, we kept the pH between 2.5 until 3.0. And then 10% of the solution consists of the sample powder. We mix it with the 2-propanol to continue with the process. And these are the equipment that we use for the characterizations. The lithometer machines we use to characterize the optical properties for the permittivity and refractive index, for UV visible spectrometer to analysis the absorption peak of the samples, and then the photoluminescence machine for the PL spectra. And then for the morphology studies, we use transmission electron microscope, or known as TM. So this is the result and discussion. As we know, that the silver nanoparticles have the very typical absorption peak at 423 nanometer wavelengths. It shows that the nanoparticle produced in the synthesis process is spherical, and then with the size about 20 to 30 nanometer. And one of the characterization for the PL spectra, you can see that how the various amount of silver effect the PL spectra of the samples. You can see that the highest spectra, of course, will be the maximum volume ratio, which is 1.0, because it has more silver nanoparticles inside the nanocomposite. Next, the analysis on the surface plasma resonant absorption peak. You can see that the size of the absorption spectra depends on the amount of silver nanoparticle exists in the nanocomposite. And you can see that from the numbers of wavelength, it is blue shifted, which is to the right. Now it shows here that during the synthesis of nanocomposite, the size of the silver nanoparticle is being reduced. So then that is why you can see that there's a blue shift right to the left of most of all the absorption peak. Okay. So next one is the analysis on the TM images. We can see that from the TM images of the nanocomposite. Now this one is the 20% silver inside we put inside the host matrix. So you can see when we embed the 20% of silver, the average interparticle distance by the measurement of the images from TEM is about 15 nanometer between the nanoparticle. And then from the optical studies, we found out that the permittivity for this 20% volume ratio is 2.26 and the refractive index is 1.42. And the next one is when we put 60%, you can see that the reduce in the distance between the interparticles, and the permittivity is negative 0.88 and the refractive index is 0.63 on the 650 nanometer. Then when we put more silver nanoparticles within the host, you can see that the distance between the particle almost zero. And then the permittivity for this maximum composition is a negative 1.25 and the refractive index is 1.06. So you can see that there is a changes in optical properties can be tuned according to the amount of silver that we put into the host matrix. And then from the optimum compositions, we do peer studies. So you can see that for the optimum composition at 60% silver in the host matrix, we find that the highest peak from the absorption spectra is at pH 9.4 compared to the other pH. So the conclusions that from this research work, it is proven that with the changes in the amount of silver inside the host matrix, we'll be able to tune the optical properties of the silver silica nanocomposites. And this is basically the research on to develop the basic foundations of the material for further application, whether in optics, whether in electronics, or in water splitting applications. I think that is all, Dr. Zaira. This is the end of the slide. Thank you very much.
Doctor, the sound is breaking down.
I think the sound, I also heard the sound is breaking.
Okay, I nak on camera.
Suara saya putus-putus tak?
Bukan Cik Taifun Hisham. Unfortunately, Dr. Zaira is the one breaking up on us.
Okay.
Dr. Zaira, do you mind refreshing? Yeah, because we cannot hear you. I don't. Afrin, can you confirm? Can you hear Dr. Zaira?
No, we cannot hear you. Maybe you have to refresh or turn off the camera. No, the
still
sound,
breaking.
yeah.
Can
Sound
you
is
refresh?
still bad. Sorry for the inconvenience.
Let's give Dr. Zaira a minute or two. Okay, she's back. Can you try speaking, Dr. Zaira? Oh, that's bad. Okay, if Dr. Zaira doesn't mind, I can help take over from here. Are you okay, Dr. Zaira? Give a thumbs up if you are okay with it. Or do you want to try? Okay. All right, me and Afrin will do our best. Okay, Mr. Typhoon Hisham, thank you for your presentation. A very good presentation, I might add. Okay, we will go to the Q&A. So we'll go to the Q&A tab first. Mr. Typhoon Hisham, we have a question from from Ishraf Islam. Dear Mr. Typhoon Hisham, our group also use sol gel to produce powder, and it is quite hard to obtain pure powder. May I know what is the purity of your produced powder?
Okay, thank you very much for the question. So from our XRD characterization, we only find silver inside the nanocomposites. So I didn't show you the result on XRD. So we have basically 4 peak, which is at 111 plane, 200, 220, 311 plane, which shows that this is the characteristic of silver. There's no other peak on the XRD that we found. So it is confirmed from the XRD that it is very clear the only particle exists in the nanocomposite is silver. Hopefully answer your question, Mr. Ishraf or Dr. Ishraf.
Okay, thank you for the answer, Mr. Typhoon Hisham. We will move to another question from Mr. Ishraf. It is important to prepare a stable suspension when dealing with EPD. May I know if you determine the zeta potential and what is the suspension media and voltage applied used for EPD?
Right. We haven't done the zeta potential because why we tried with this during the MCO because why I'm staying in Gambang, you see. So, but then about the suspension, we use the propanol, and then regarding the voltage, we use 80 volts. 80 volts. We are within just 5 minutes of EPD process. Why we use 80 volts? Because why to maintain the optimum thickness, and then the timing also very important. We just maintain just within 5 minutes of the process. Hopefully you answered the question.
Okay, thank you for the answer. Is there any more question? Let me check the set. Okay, he's happy with the question. So we are almost at the end of our session. Now at the end of the session, we would like to remind you that we had a competition among the presenters also, and we were supposed to declare the best presenter today. Our chair session would have done that. So according to the honored evaluators, after calculation, we have found that Ms. Mudrika is the best presenter today. Lukman, no sound. Look. So congratulations to Ms. Mudrika, and thank you very much, our evaluators, for your kind effort.
Thank you very much.
Maybe at the end of the session, you also take a photo.
Sure, why not?
Okay, so
our Prof. Rafi is here.
Okay. So, Salam, Prof. Rafi. We have just declared that our best presenter today is Miss Mudrika.
Thank you.
Thank you for joining us.
Shall we take one last picture with,
Yes,
on
please.
this note with Prof. Rafi here? Dr. Steven, Mr. Shafiq, Dr. Suresh, if you would join us. Dr. Steven, Mr. Shafiq, if you're still there. Calling one. Okay, hi. Okay, hi guys. All right, I'll be taking a picture in 3, 2, 1. All right, thank you very much.
Thank you.
Dr. Zaira, you may close.
Thank you so much.
Okay, thank you everyone. Thank you, Rutanera. Thank you, Prof. Thank you, Lukman.
So we declare, Dr. Zara, you want to try for? Okay. Cannot hear, right? Can you hear, Lukman?
Unfortunately, I cannot hear Dr. Zaira.
Okay. Okay, thank you all very much, all presenters. So now we are going to finish this session, and again with thanks, and you are welcome to visit all the sessions tomorrow also, and our conference is continuing tomorrow and day after tomorrow. Very interesting presentations will be there. You all are welcome to join us. Thank you and assalamu alaikum. Lukman, you want to add something?
No, nothing. Thank you guys, and don't forget to fill the form in the event section. Thank you.
Yes.
So can I leave now?
Yes, you can. Thank you, doctor.
Okay. Thank you. Okay. I did not take my lunch.
Oh, so
I will go
sorry
to
for
take my
you.
lunch. No problem. Thank you.
Sorry to hear
Take
that.
care. Okay, take care and
Thank
be
you.
safe. Okay, thank you.
Afrin, Dr.
Okay,
Zaira,
bye.
thank you. Afrin, mind staying for a bit?
Just waiting for everyone to leave.
Yep. Okay.
So we can go. So we have to go somewhere now?
No, just want to talk, just want to wrap up things with you. First of all, first and foremost, thank you so much for covering a lot of my
No, I
mistakes.
didn't cover much.
Oh my God.
I was not ready with the clapping. Otherwise, I could play
Okay,
that.
I want to ask you, the last clapping, did everybody hear, or there was no clapping at all?
No clapping.
Unfortunate. Sorry.
You were mute.
Because I was mute. Yes, I saw it too late. That was mute. When I shared the screen, I forgot to press the share audio as well.
No,
So
but
that's my
you took over very promptly from Dr. Zaira. Thank you.
Well, things happen. We have to expect that. And you help a lot, especially with the evaluation form. Okay, so regarding the picture, did you take any picture? Control screen for Miss Ina?
Miss Ina?
Ida. Miss Ida, yeah.
No. You
Okay,
also don't have?
Hi, doctor.
Now the sound is okay?
Still no sound, unfortunately,
No sound.
doctor. Sorry, doctor.
In this kind of situation, doctor, you can join from phone also. Because at least for phone, the sound has no problem.
Or you can try plugging an earphone with a microphone. That's another way. You can try trying to read your lips. I assume you're saying earphone with microphone. So yeah, I think it's earphone with microphone that you can use. Another way, if it's not either, it could be your mic in your laptop that is a bit old or having a problem. But I think this laptop is new, right? You mentioned. So there should be no problem there. So the last problem might be due to internet. That's it. That's all I can think of.
But another thing, Lukman, how about networking? We didn't mention anything at all.
Yeah, it's okay. For
because
the 7
one
people,
person wanted to meet Dr. Asmalina.
For the 7% that's still watching, you can try networking. It's right on the left tab under sessions there, and you can try to get Dr. Asmalina, the person who wants to meet Dr. Asmalina. So sorry for the late announcement. It's our first day as well. So yeah.
Yeah.
Okay, Afrin, thank you so
Okay.
much.
Thank you so much. Bye. Thank you,
If you
Dr.
have
Zara.
anything, just send me through. If you have any follow-up issue, just send me through WhatsApp.
Okay. Okay.
Okay. Thank you, Dr. Zaira. Thank you, Afrin. Thank you, everyone who's still watching. Bye-bye. Assalamualaikum.